Jan 2026 M1 question number 1. So a particle P of mass 3m and particle Q of mass 5m are on a smooth horizontal surface. The particles move towards each other in opposite directions along the same straight line and collide. Okay, so the particles moving on a straight line. Let's say P is moving. This is P, which is 3m. It's moving on the right, let's say, and opposite direction would be 5m Q. It's moving on the left. So I need to set the convention. So I'm taking, for this particular math, the right hand side would be positive and the left hand side would be negative, or vice versa. You can take the opposite. Let's say if you take right hand side as negative, left hand side is positive. So I'm taking this first one convention, but you can take the second one as well, no problem. Okay, so impulse was given. Impulse immediately before the collision, speed of so initial velocities are given. So initial velocities of P is 3u, since it's moving on the right hand side, so it's positive. And initial velocity of Q is given as 4u, so negative 4u, because it's moving on the left. This is our convention. Okay, the magnitude of the impulse exerted on P by Q. Okay, so the impulse, they collide. Since they collide, so it produces an impulse. So since P is moving on the right, and Q is moving on the left. So impulse in P would be on this direction. Okay, this is impulse on P. So since impulse is occurring at the left hand side, so impulse would be negative. Okay. So they're asking us to find the speed of P immediately after the collision. Okay, so it's very simple actually. So we simply need to know the formula for impulse. So impulse on P would be nothing but mv minus mu. So the definition of impulse is basically change in momentum. Okay, this is change in momentum. So mv minus mu, and we need to find, we can use this equation to find the final velocity of P immediately after the collision. Okay, so impulse on P is 33 by 2 mu. So negative 33 by 2 mu. Mass, we can take mass common, so 3m, the mass of P, and velocity we need to find, and initial velocity was 3u positive. All right, so we can simplify this. This would be we can cancel out this m as well. Okay, we can cancel out this m. So minus 33 by 2 u equals to 3v minus 9u. So it would be minus 33 by 2u plus 9u equals to 3v. Or finally, it would be 1/3 minus 33 by 2u plus 9u. That would be v. So the final velocity of P will be minus 2.5u. Okay, in the second part of the question, it says speed of Q immediately after the collision. Okay, the speed of Q, it's required to, we need to find the speed of Q after the collision. So since P and Q, they both collided. Okay, so there's an impulse on Q as well. So the impulse on Q would be on the right hand side. Okay, that would be IQ. So all we need to find, IQ. So all we need to do is we need to simply find the change in momentum of Q. So mv minus mu, and the magnitude of the impulse would be same. So IQ would be, since it's on the right hand side, so it would be positive 33 by 2 mu, and the mass of Q was 5m. We can take it common, so vq minus initial velocity was minus 4u. We have done that in the initial part. So this m can cancels out. So 33 by 2u equals to 5vq plus 20u, and that would be 33 by 2u minus 20u, so 1/5, and that would be VQ. So VQ would be equal to minus 0.7u. So these are the two answers. Okay, thank you.